Hi, in this video we're going to look at how to find expressions for inverse functions. So let's look at a typical example. The functions p and q are such that px is equal to x squared minus 4 and qx is equal to 3x plus 2. What is the expression for p minus 1x and q minus 1x, and how do you solve p minus 1x is equal to q minus 1x? Well, before we answer this question, let's briefly look at what functions and inverse functions are. A function is a relationship between an input variable and an output variable. You most likely have seen this as something like y equals x squared, y equals 2x plus 1, or y equals 1 over x, etc., where x is the input variable and y is the output variable. These are examples of equations that are also functions, but these functions could also have been written as fx equals x squared, fx equals 2x plus 1, or fx equals 1 over x, where fx just means that the output is a function of x. So fx means the same thing as y, but it doesn't have to be the letter f either. We could have written these as qx equals x squared, qx equals 2x plus 1, or qx equals 1 over x. And the variable doesn't have to be x either. For example, we could have had a instead, so that the function is fa equals a squared, fa equals 2a plus 1, or fa equals 1 over a. So the letters are arbitrary too. So don't be concerned with px equals x squared minus 4 and qx equals 3x plus 2 in this question. It just means the same thing as y equals x squared minus 4 and y equals 3x plus 2. And graphically, px equals x squared minus 4 can be represented like this graph, with px on the vertical axis and x on the horizontal. Or like this, with y on the vertical axis and x on the horizontal. They mean the same thing. Okay. Let's now look at what the function px is equal to x squared minus 4 in this question is doing. First, draw a set which contains some values of x which you're able to put into the function. I'm going to choose minus 2, 3, 5 and minus 3. This set of values, of which there are many more, is called the domain. Next, draw another set which will contain the output values for each input value of x. So if you put minus 2 into the function px is equal to x squared minus 4, you get minus 2 squared minus 4, which is equal to 0. Similarly, for the other values of x, you get 5, 21, and 5 respectively. This set of values is called the range. So the function px takes a value of x from the domain and produces a value in the range. Notice how both the 3 and the minus 3 in the domain of this function produces the same value of 5 in the range. This means this function is called a many-to-one function. A function where only one value of the domain maps to one value of the range is called a one-to-one function. Okay, so that is what a function is, but this question asks us to find the functions p minus 1x and q minus 1x. So what are those? Well, these are called inverse functions, which are functions that undo another function. To explain these, look again at the domain and range diagram. The inverse function, p minus 1x, uses a value of the range and takes you back to the corresponding value of x. For example, p minus 1x takes the value 0 and produces minus 2. This function is what we have been asked to find. Okay, so let's now answer part A and find the expression for the inverse function p minus 1x. First, write px equals x squared minus 4 as y is equal to x squared minus 4, as these mean the same thing, as we've just seen. Then, rearrange this equation to make x the subject. So we have x squared is equal to y plus 4, so x is equal to the square root of y plus 4. Now change the x to p minus 1x and the y to x. So p minus 1x is equal to the square root of x plus 4. We can check this works by looking at the domain and range diagram again. Put a value of the range into this function and see if we go back to the value of x in the domain. Let's try 21. So p minus 121 is equal to the square root of 21 plus 4. So p minus 121 is equal to 5. So it does work. Let's now answer part B. What is the expression for q minus 1x? First, write qx is equal to 3x plus 2 as y is equal to 3x plus 2. Then, rearrange this equation to make x the subject. Well, 3x is equal to y minus 2, so x is equal to y minus 2 divided by 3. Next, change the x to q minus 1x and the y to x. So we have q minus 1x is equal to x minus 2 divided by 3. Okay, now let's answer part C. How do we solve p minus 1x is equal to q minus 1x? First, let the square root of x plus 4 be equal to x minus 2 divided by 3. Then, square both sides to remove the square root on the left-hand side. So we have x plus 4 is equal to x minus 2 squared divided by 9. Next, expand the brackets on the right-hand side. This gives x plus 4 is equal to x squared minus 4x plus 4 divided by 9. Then, multiply both sides by 9 to remove the fraction on the right-hand side. So we now have 9x plus 36 is equal to x squared minus 4x plus 4. Now subtract the 9x and 36 from both sides to give 0 is equal to x squared minus 13x minus 32. This is a quadratic equation and it's not going to factorize, so we can either use a calculator or the quadratic formula to work out the solutions. Let's use a calculator. If you've got a Casio ClassWiz, we press Menu and then scroll to Equation/Function, then select 2 for polynomial and 2 again for polynomial degree. Then enter 1 for the coefficient of the x squared term, minus 13 for the coefficient of the x term, and minus 32 for the constant term. This gives 15.1 for the first solution and minus 2.1 for the second solution. So x is equal to 15.1 and x is equal to minus 2.1. But because the question in part C states that x has got to be greater than or equal to 0, we can reject the negative solution. So x is only equal to 15.1. Okay, so that is how you answer a typical question asking us to find inverse functions. I hope you found this video useful. If you did, please give it a thumbs up and subscribe to my channel where you'll find more videos for GCSE Maths. Thanks for watching.